Hi, welcome once again to our lesson on change of subject. Today we are on lesson 6, case 6, where we are going to talk about relations where the required letter we are supposed to make the subject is either squared or cubed. So if you find the required letter in a cubic sign or in a squared sign, what are you going to do? That is what I want us to look at now. Kindly, if you have not subscribed, subscribe it and like it so that you can have the next lesson on this. All right. So the first thing you need to do is that for such relations, simplify the relation such that the square or the cube will stand alone. When the square or the cube, the relation with the square or the cube stands alone, then you can now eliminate the square. If you want to eliminate the square, you square root both sides of the equation. All right. So if it is squared and I want to eliminate it, I'll square both sides of the equation. If it is cube and I want to eliminate the cube, I will take the cubic root on both sides. So that is that. Let's take an example on this. This is a very nice example. We are making the first one, we are making Vn the subject. And the second one, yes, we are making Vn the subject in each case. So the first one, we have u squared equals Vn squared plus pi d. And the second one, we have L squared equals 2 pi V cubed over G. So let's look at how we can solve this question based on what I'm seeing. All right. So we have U squared is equal to V squared plus pi D. So we ensure that the V we are making the subject is squared. So how do we ensure that the V squared is standing alone? We need to eliminate this, which is adding. So if I subtract the pi d on both sides, I'm going to eliminate it, just as we have discussed in our previous lessons. So here I'm going to take away, get it, so I'll get 0 there. So we are going to have pi d equals v squared. So you see what I was trying to say. Now we see we have ensured that only the required letter is standing alone. Right, so the next step, since the v square is now standing alone, I can eliminate the v squared by simply taking the square root of both sides. So if I take the square root, what will happen is that the square root will cancel this square, because the square root of v squared, as we know from indices, is the same as v squared exponent half. All right, so it will go. So go back. So if I take the square root, it will be left with v u squared minus pi d. Good. So that answers the first part. Now let's look at the second part of the question. That one, we are asked to, we are given L squared equals 2 pi v cubed out of G. So you see that this relation involves fraction. So we are going to ensure that the v cube stands alone. So we are going to multiply through by the LCM. This is over 1. So the LCM of the denominators will be G. All right. That is G. So what am I going to get? What are we all going to get? L squared times G, 2 pi v cubed G times G. All right. So that we move on, we are going to get L squared G. The G divides the G, you get 1. So it cancels it out. So v cubed, all right. Now what do I do so that the v cube stands alone? Now the 2 pi is multiplying the v cube, so we divide through by the 2 pi. So we divide through by the 2 pi. Please, I hope you are enjoying. Then the next one, so now this cancels this, all right? So I won't cancel it. I just want you to know. So I will have this L squared G 2 pi. Now our v cube is standing alone. What do we do to eliminate the cube? If it is cube, you can eliminate it by taking the cubic root. Okay? And that is how you write the cubic root. L squared 2 pi. This is because if I take the cubic root of v cube, what this means is that is v cube exponent 1 over 3. That is the meaning of the cubic root, right? So it goes. It goes. So we will have it v, which will be the cubic root of L squared G over 2 pi.